Hi guys, Patrick here with goldkilns.us. Let's see, the other day we shot a couple of videos. One of them was crushing some high-grade sulfide gold ore, and then the other one was concentrating it on the miller table. So the next step in the process in taking the gold out is to go to a roasting process. And when you're working in the smelting, there's really two environments that you work in. You work in either an oxidizing environment or a reducing environment. And the roasting takes place in an oxidizing environment. In other words, we want to take a sulfide ore, oxidize it, drive the sulfur off, and replace it with an oxygen molecule. The ore that we crushed and concentrated the other day is in this little plate right here. And if you'll notice, this little stuff is it's a light colored, almost a whitish color. There's a little bit of silica left in here, which is a good thing anyway. And so that's the ore that we happen to be working with. And that's the color of the sulfides there. This little plate here is a totally different sulfide. This plate's real brassy colored. This is what is typically what I would call just basically an iron pyrite. The reason this plate here with the material that we're working with is a different color, it's a lot whiter, it's almost a white iron color, is because this is alloyed, and this is what we would call arsenopyrite. In other words, there's iron and there's arsenic in it, and sulfur. And so the chemical equation would be FeASS. One atom of iron, one atom of arsenic, and one atom of sulfur. So any of the gold that I've found associated with pyrites typically is much higher concentration when it's an arsenopyrite than just a straight pyrite. Not necessarily the full rule, but that's what I have found. One of the things that we also are going to do is we are going to add some silica sand. This right here is 70 mesh silica sand, which is silica dioxide, SiO2, to our ore when we roast it. Basically that helps keep it from sticking to your pan, and there's a whole lot of other benefits. We have to add some silica when we use the litharge flux, etc., etc. So we're going to roast about 150 grams of the material that we concentrated, and so I'm going to throw 15 grams of silica sand in there when we do it. Next thing that you'll see sitting here is charcoal, which is carbon. And once we drive the sulfur off of the iron, the arsenopyrites, etc., etc., and replace it with an oxygen molecule and everything, we're going to add a little carbon to reduce some of the arsenic back down, let it ash off, and then get rid of the arsenic by volatilizing it off. Doesn't take a whole heck of a lot, but it just makes things a lot cleaner when you go through and do your litharge and your flux. So, at any rate, we're going to use ore. We're going to add a little silica sand, and then we're going to roast it. And what we're going to use to roast it is over there. That's KK8, and there's a metal gold pan on top of it, which I like to use for roasting. Transfers heat very well. A scale, and there's a mass there, a respirator, and everything. So it's a little hard to see over there right now. So what I'll do is I'll stop and I'll move the camera a little closer so that you can see all that stuff over there, and I can explain it to you. Hang on. Okay, I'm back. One-man band here, guys. Okay, so this is a metal gold pan. Big old metal gold pan. I'm a fan of metal gold pans. And this is the top of the KK8, one of the furnaces that GPK and us build. And on top of it, I've put 3 little ceramic pedestals. And what we'll do is we'll light the KK8 up. We'll run the temperature around 14 or 1500 degrees. And what that'll do is that'll bring the flame out the top. And then when we place our pan on there, like so, it's lifted up so the flame can come underneath of it and heat the pan up. And we'll lose a couple hundred degrees when the flame is hitting the pan there and is exposed to the atmospheric oxygen. You don't want to roast over 11 or 1200 degrees. If you start getting hotter than that, what happens is you fuse the iron, and that just makes it really, really difficult to deal with after that point. So we're looking for 11 or 1200 degrees in around that area. The bottom of the pan will be cherry red, and that's just super ideal. Once we have our material roasted and we go to fluxing it, we'll use another little thing here. See if I can get this over there. This is a KK6 over here that's modified with this ring on here for cupelling lead prills off. And the litharge is a lead oxide flux. And basically what we do is we go into a reducing environment inside of a crucible. Once everything's roasted, we'll add our litharge flux and some other materials, plus a little bit of carbon, and we'll precipitate a lead prill of a given size. Now this right here is the typical size cupel that is used in a fire assay. These are bone ash cupels from DFC ceramics, best you can buy. And basically they'll hold about 30 grams, 35 grams of lead. And when you're doing a fire assay, you try and precipitate a lead prill about this size. This weighs about 27 grams. And the lead collects all of your metals in your fire assay. It goes into the cupel, and then once it's into the cupel, you convert the metallic lead back to a lead oxide, which is a litharge. The cupel absorbs the litharge, but not the precious metals, and you end up with a bead of gold, silver, or whatever you're assaying for. The KK6 uses a much larger cupel. This cupel is 3 inches across, and it will hold several hundred grams of lead, which is a super advantage when you're trying to control the size of your lead prill in a recovery type thing. If you look at that size of that lead prill in there, it's minuscule compared to this cupel. But we're kind of getting ahead of ourselves. So at any rate, that's the ultimate type of it. The end product that we'll get to is we'll perform basically a large fire assay in order to get the gold out. So, getting back to where we're at, one of the phenomena that happens when you roast a sulfide ore is you drive the sulfur off, and once the sulfur is gone and you replace it with an oxygen atom, you're actually changing the material from an Fe2S, a sulfide base or whatever, to an oxide base. And typically it will grab a couple of oxygen molecules and become Fe2O3 or Fe2O4 or FeO or whatever. And once you do that, the material now becomes magnetic. This right here is our material that's not been roasted. These are our sulfides. And in this little bag right here is some neodymium magnets, some rare earth magnets. Now, when we take this material prior to roasting, and if we run this magnet around it, we get absolutely no reaction because the iron is still in a sulfide state. It's FeS2, 1 atom of iron, 2 atoms of sulfur. So it's not reactive to a magnet. Once we roast it, it becomes an oxide. And the oxide, it would be an Fe2O3 or whatever, and that material then becomes magnetic. So we can take this material and roast it, and now we have an iron oxide which is further able to concentrate by magnetics, because this material is no longer non-magnetic, it is magnetic. So it helps us to get to the final nth degree a lot cleaner. And at any rate, what we'll do is, in here I've got 100 grams, and over here there's 50 grams of this material right here. So I'm going to put this 50 grams of material in here and come up with a total of 150 grams in that little jar. I'm going to add this 15 grams of silica sand, silica dioxide to it, and put it in a jar like so. Screw a lid on it and shake it up. Roll your crucible, roll your jar or whatever prior to putting it into the gold pan to roast it, so everything gets mixed up all right. And I'll pour that back out, and for right now in that little thing we're going to run about 150 grams or whatever in that roasting process. So that's what our material looks like right now. Is that's going to go into the gold pan, which would be sitting on top the KK8. We're looking for a temperature of between 11 and 1200 degrees, and we'll go ahead and roast it. Once we get all of the sulfur dioxide and everything off of it, then we'll add a little bit of charcoal to it. I'll crush that charcoal up. We'll add a little bit of charcoal to our material after it's cooled off a little bit, and then we'll place it back on the KK8, and we'll get it hot again, and we'll bring it back up to temperature, ash the carbon off, and that'll take the residual of the arsenic with it. Now, two things. Sulfur dioxide and arsenic fumes are obviously not a good thing. So you want to stay out of the fumes coming off it. You also want to wear a good half-face respirator. These cartridges are fully compatible and will filter out sulfur dioxide, a whole bunch of different types of fumes and everything. So I wear this respirator and I stay the heck out of the fumes until all of the sulfur dioxide is gone. It doesn't generate a whole heck of a lot of it, but it's just a matter of being safe. Smells pretty bad, to say the least, but it only takes 10 or 15 minutes to get rid of the majority of the sulfur. All of the smell goes away, and then we proceed on down the road. Roasting process will take probably 30 minutes. Then we'll let it cool down a little bit. We'll add our powdered charcoal over there, and then we'll heat it back up again, probably run it for another 15 minutes or so. Let it cool down, and then we'll have the material that we're also going to place back on the Miller table with these rare earth magnets here attached to the bottom of the Miller table. We'll run a stream of water across there, and we'll grab all of the magnetics. Magnetics will be the material that has the gold in it, and that way we'll get rid of any excess silica dioxide or whatever that we added to it, and or any little bit of gang material that's left. Pretty simple, even a lot more simpler once we get it going. So I'll get set up out here. I'll get the furnace set up, I'll get it lit and bring it up to temperature, and then we'll take off and we'll roast that material, turn it into an iron oxide, which we can further concentrate by magnetics. Once we get it concentrated as best as we can with the magnetics, then we'll go into the litharge stage in the crucible with the flux, and we'll add enough flour as a carbon source to produce a lead prill of approximately 30 grams. Sulfur is a reducing agent, so if you don't get 100% roast on your ore, if there's a little bit of sulfur left, it'll produce a little bigger lead prill, But doesn't really matter because we got a Qpel with the KK6 that'll take care of any of the oversize that we have. We don't have to do any scorification or whatever. So at this point, I'll shut this thing off, I'll get set up, and I'll show you how we roast this stuff. Hang on, I'll get back to you. Hi guys, I'm back. I cheated a little bit. I already had the KK12 set up. Been using it for smelting some mirror sludge. It was already on the table and everything. Same burner, same unit, just bigger. And I've got it up to temperature right now. It looks like it's running about 1600, a little warm. Might turn it down. So anyhow, I'm going to set this pan on there. And once I get that pan set on there and it starts smoking or whatever, I'll have to put my mask on and everything. But at any rate, I'll get it set on there, and it's pretty hot sitting out here in the sun. Whatever, it's going to be another one of those 100 and some odd days. Nice day in Arizona. But anyhow, let me get this thing set on there and we'll leave it run for a little bit and see how things go. Back this camera up a little bit too. It's quite a bit of heat coming out of there. Maybe I'll go over here. I can't see Dick. So let's see if you can. That's better. Whew. Starting to smell pretty bad already. So I'm going to throw that mask on. When you go through this process, you want to stir that material. Make sure you keep it exposed to the atmospheric oxygen. So I'll stick my mask on, I'll get my little stir deal, and we'll let her go for a little bit. Yeah, I don't know if you can see or not. I backed off a little bit. It's that pan is just glowing red hot under there. I put those little extra pedestals in there. We got quite a bit of wind blowing here today to kind of keep the flame up underneath it. So I'll stop this for right now, and we'll go ahead and let it roast up. Still a little smoke coming off of there, etc., etc. Then we'll let it cool down. We'll add some charcoal. Hang on, I'll get back to you. Okay guys, I'm back. We went through and we roasted that. Been on there for about 40 minutes. One thing I want you to notice is I want you to notice the color of the material now. We've gone from that blonde looking material to it's definitely red, and that's the indication of a complete roast. It's converted from an iron sulfide to an iron oxide, probably Fe2O3, a hematite, because hematite's red. So now what we'll do is we'll take our charcoal now. I got 5 grams of charcoal there, and we'll throw, see, I'll get that and see if you can see what the hell I'm doing. Yeah, okay. We'll take this 5 grams of charcoal here, and we'll throw it in there. And we'll mix it up as best as we can. I couldn't find my putty knife, so I'm stuck using this, but it's working all right. Like I say, this is why I like gold pans. So, we pretty well got it mixed up in there. We'll mix it as we go again, of course. The idea is the charcoal is a carbon, which is a reducing source. So reduce any quote-unquote residual arsenic down, and then it'll volatilize off as the heat is applied to it. So we're pretty good there. Just flatten it out a little bit. Let's see, I'll turn this camera up a little bit. Man, I can't see nothing out of there. It's so bright. Oh yeah, okay, there we are. All right, so I'll just set this back up on top there. Center it. I'll probably let it go about another 30 minutes or so. During that time, of course, I'll be stirring it and everything. But 30 minutes of watching that's kind of boring. So hang on, once I get that all done, I'll set you up back up in the garage there and show you the difference and show you the magnetic effect. Hang on, I'll get back to you. Hi guys, I'm back. Okay, we finished up our roasting, and I want to show you the difference. This material right here, this whitish colored sandy looking material, is what we started with. This is the material after we performed an oxidizing roast. As you can see, it's red, which is obviously because now, instead of it being an iron sulfide, now it is thoroughly oxidized. We've driven the sulfur off. We replace the sulfur atoms with oxygen atoms, and now we have a rusty red looking material after roasting. We roasted it for about 30 minutes, maybe more, maybe a little more. Added the charcoal to it to reduce any remaining arsenic, and then we roasted it again to drive anything off. And this is what the material looks like when we're done. Now, I'll show you the phenomena about the magnetics. I'll dump this back in the bucket. So I've got another plate here. And what we'll do is I'll take our rare earth magnets again, our neodymium magnets, and I'm going to run it around here, and you can see what it's doing is it's moving that material around. So I'll hold a magnet there, and I'll go ahead and pour some of this into this other plate. And as you can see, now our material has become magnetic. And that's important when we want to do our final concentration, because we can concentrate it by grabbing what we want to get with the magnetics. So, converted it from a sulfide, which is not magnetic. I'll grab a little scoop of that again. This is our sulfide material before we roasted it. Zippo. After we roasted it, turned it into an iron oxide. There you are. Kind of cool. So, interesting phenomena. Not a lot of people know about it. Next step, obviously, is to do a crucible fusion using the litharge flux. Well, that's not the next step. That's the ultimate goal. We're going to take this material that is now magnetic, and we're going to run it over on the Miller table again, and we're further going to concentrate it. We'll get rid of a lot of the gang material, etc., etc. And at any rate, then we will do the crucible fusion and with a litharge flux and end up with a lead prill that looks similar to this, probably a little bigger, and then with pellet, and we'll look at our gold. That's about it for today. So, thanks for watching. I'll get back to you.